Today we're covering some material in preparation for section 3.3. We're going to look at adding, subtracting, and distributing. So basically combining like terms of polynomials. And then we're also going to practice completing the square. We saw this in lecture for 3.2, but I want to practice it again because it comes up again in section 3.3. So, looking at our first example, we want to simplify each of these expressions. Sometimes when we're kind of adding different polynomials and things, we end up with extra parentheses around things. We have to get used to just paying attention to when the parentheses are relevant and when they're not. So with this first example, I have a bunch of terms inside parentheses, but nothing's being distributed in the front, and there's nothing being squared up here with an exponent. So these parentheses actually are not necessary. They're not really gathering any operations together. Then if you look here, since this is addition, there's no sign change going on. There's no exponent up here. And so this second set of parentheses is also somewhat redundant. So essentially, this is the same thing as if I write it straightforward like this. Because we didn't really need to have those operations grouped together. So we drop the parentheses here, and now we're able to combine like terms. Remember, like terms are things that match in the variable and the exponent. So things like 3x squared and x squared can be added together. In fact, that gives 4x squared. And then I have a plus 5x and a minus 4x. So that's plus x. I have a minus 2 and plus 7, which is plus 5. So with that first one, we just combine the like terms as usual. Now looking at the second one, the first set of parentheses is that same case. There's no coefficient in the very front. There's no exponent. But with the second set of parentheses, with that minus sign, that minus needs to be distributed to each of the three terms. That's the only way we can break up the second set of parentheses. So I'm left with 5x squared plus 2x minus 1. Now I'm going to distribute the minus. So minus 3x squared plus x minus 4. This is one of the most common mistakes I see in mathematics, is forgetting to distribute your negative. Very easy to do. Even people who do it all the time, like myself, will absolutely forget. But it's very important in this course, so try to pay attention. So we've distributed our minus here. Now let's combine our like terms. I have a plus 5x squared in the first term, then a minus 3x squared, so that gives me 2x squared. I have a plus 2x and a plus x, that's plus 3x. And I have a minus 1 and a minus 4, that's a minus 5. There we are, combining those like terms. Now on to the next one. I have a minus in front of my first set of parentheses, in front of the 2x minus 4. And then I have a minus 3 in front of the second set of parentheses. So I actually need to do a bit of distribution before I can break up either of these parentheses. I need to distribute my first negative to minus 2x plus 4. And then I need to distribute the minus 3. So minus 3x squared plus 15x, because the minus 3 and the minus 5 make a plus 15, and I have 1x. And then minus 3 times 6 is minus 18. Now I combine like terms. I have minus 3x squared. I have a minus 2x plus 15x is plus 13x. And then I have a plus 4 to minus 18. That's minus 14. There we have it. We've combined all the like terms, and we did all the distribution properly. So we didn't drop any negatives here, and that's what helped us get to the right answer. You can have a vastly different answer if you make little mistakes like that. Moving on to completing the square. Remember that the term that's important for completing the square is adding b over 2 squared to both sides. That's after you have all x terms on the left. And not only all of them, but only x terms on the left. You have your non-x terms on the right. That's when we add that b over 2 squared to both sides. It's also helpful to remember that we're talking about equations in the term of ax squared plus bx plus c. Okay, let me draw lines. We remember that is for this example. Now, looking at x squared plus 6x equals 8. I have all of my x terms on the left and all of my non-x terms on the right. So we're set there. So now I want to look at adding my b over 2 squared term to both sides. Well, here b is 6. It's what's sitting in front of my x with 1 in the exponent. So my b over 2 squared is 3 squared, which is 9. So b over 2 is 3, which means b over 2 squared is 9. So now I take x squared plus 6x plus 9 and equals 8 plus 9. That's what was added on both sides. And now my left-hand side factors nicely. I get x squared plus, oops, that's not what I wanted, x plus 3 squared. It ends up being some term squared, and so you look at your factor and you actually end up getting x plus b over 2 quantity squared. And this is what equals 17. All right, so now what we can do is look at x plus 3 quantity squared equals 17. To solve this, we're going to take the square root of both sides. And then we get x plus 3 equals the plus or the minus of the square root of 17. Because both of those would square to positive 17, either the positive or the negative. So now what this really means is x plus 3 can equal positive root 17, or x plus 3 can equal negative root 17. We have no way of telling if it was the positive case or the negative case when we got to 17, is kind of the idea. In either way, we subtract 3 from both sides, and we get x equals negative 3 plus root 17, or x equals negative 3 minus root 17. And that is our answer for this problem. Root 17 can't be simplified at all, so we're done. Now let's look at 2x squared minus 7 equals negative 8x. I'm going to make it bigger, so that way I can write in this smaller space. Maybe I won't make it quite that big. There we go. We're going to focus in right under in B. Okay, let me give myself that extra room. So now we're looking at 2x squared minus 7 equals negative 8x. We got to do a couple things to this. So we need to do, get all of our x's to the left-hand side, so plus 8x to both sides. And we need to move this minus 7 to the other side. So we get 2x squared plus 8x minus 7 equals 0. And now we'll move our 7 to the other side. 2x squared plus 8x equals 7. So we added it to the other side. Now in order to complete the square, I need my a value to be 1. So I need to divide both sides by 2. I get x squared plus 4x equals 7 over 2. Now we can complete this square. This is of the form where I have my a equal to 1 here. There's no coefficient in front of my x squared. And I have all of my x terms on the left, non-x terms on the right. So we look at what is my b value? Well, it's 4. So my b over 2 is 2. And so that b over 2 squared term I'm looking to add is back to 4. 2 squared is 4. Okay, so this becomes x squared plus 4x plus 4 equals 7 over 2 plus 4. And that means that my left-hand side can be factored as x plus 2 squared equals, and then 7 over 2 plus 4, that's 7.5, which is 15 over 2. You could put that in your calculator if you're not sure. But that tells me that if I take the square root of both sides, I'm getting x plus 2 equals plus or minus the square root of 15 over 2. And so I subtract 2 from both sides, and I get that x can be plus or minus the square root of 15 over 2 minus 2. Which, of course, I don't want to write in one line. You'll more often see it written x equals square root 15 over 2 minus 2, or x equals square root 15 over 2 minus 2. That guy has a negative out front, right? The plus or the minus of the square root. And so that's it for that problem. Please give it a try, practice combining different like terms, and then also solving completing the square. And as always, reach out if you have any questions.